Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at arithmetic series. So a series is just the sum of terms in a sequence. So we denote it Sn, that means the sum of the first n terms. So for an arithmetic series where you're adding up the terms of an arithmetic sequence, we can use this formula. Sn equals n over 2, 2a plus n minus 1d. So S is the value of the sum, N, A, and D have the same meaning that they did when we looked at arithmetic sequences. N is the number of the term, A is the first term, D is the common difference. And there will be a common difference, otherwise it's not arithmetic. So, for example, let's calculate S25 for this sequence here. That means we're calculating the sum of the first 25 terms. So that means N is equal to 25. So it'll be n over 2 times 2a. So 2 times the first term, 2 times 150 is 300, plus n minus 1, so n was 25, multiplied by d. Now here the value of each term is going down by 9 each time, so d, the common difference, is negative 9. So putting that on our calculator, we simply get 1050 and we're done. All right, let's look at another example. So we're now going to add up all of these numbers here. This is an arithmetic series because we're adding the terms of an arithmetic sequence. This is an arithmetic sequence because there is a common difference. In this case, d equals 13. Each successive term is increasing by 13. It's increasing by the same amount. So clearly we have here that a is equal to 16. A is always the first term. But in order to calculate s, I need to also know n. I need to know how many terms are being added up. So what I need to do is find for this last term, which term is it? Is it the 7th? Is it the 76th? Whatever. So to do that, I'm going to use the formula from last time, Tn equals a plus n minus 1d. So I'm simply going to substitute into this equation Tn for 315, that's the value of the term, that is equal to a plus n minus 1 times d, so d being 13. So I simply subtract 16 from both sides, I get 299 equals 13n minus 1. So now I have to divide each side by 13. I get 23 equals n minus 1, add 1 to each side, n is equal to 24. So what that means is I'm actually adding up 24 terms of this series. So I'm calculating S24. It is n over 2, 2 times a, so 2 times 16, plus n minus 1 times d. So you can just put that straight in your calculator and you get 3972. All right, let's look at some harder questions. So here we have an arithmetic series and we want to know how many terms are needed to attain a sum of 2408. Now we can't use the trick we used in the last question because we don't know what the last term is. So what we're going to do is use this formula. We know S, we know A, we know D. We're going to substitute in those to the formula and then rearrange to find N. So we have S, N, we don't know N though. So that's the sum equals N over 2, 2 times A, so 2 times 5, plus n minus 1 times d. Now you can see clearly that each successive term increases by 6, so d is equal to 6. So let's just make this a bit easier to work with. So 2408 equals n over 2. So if I expand the brackets here and collect like terms, I get 6n. I get 10 minus 6, which is 4. All right, I'm going to now multiply each side by 2 just to get rid of the fraction. So I get 4816 is equal to n, 6n plus 4. Now hopefully you can start to see this is a quadratic because n times 6n gives us 6n squared. So I need one side here to equal 0. So 6n times n, 4 times n, and what I have to do to make one side equal 0 is subtract this from both sides. I'll move it over there. I get minus 4816. So to solve this quadratic, since the number here is quite large, let's just use the quadratic formula. So first we calculate the discriminant, b squared minus 4ac. We get this number here. That's good. That tells us that there will be 2 solutions. So the solutions will be n equals minus b plus or minus the square root of the discriminant, all divided by 2a, 2 times 6. Okay, so if you put them in your calculator one after the other, so one is minus 4 plus this over 12, the other being minus 4 minus this over 12, you get 2 solutions, but one of them we'll see we can't have. So one of them is 28, the other one is negative 28.6 recurring. Now, because n is the number of terms, it can't be negative, we reject this solution, and that will be our final answer. You need 28 terms of this series to be added up to get this sum. All right, let's look at one more question. The sum of the first 15 terms of an AP is 165. The sum of the next 15 terms is minus 60. We're going to calculate the values of A and D. So hopefully you are thinking straight away simultaneous equations, because we need to calculate 2 quantities at once. So we need to set up 2 equations. The first equation will come from the first 15 terms. So S15 is equal to 165. So the formula is Sn equals n over 2 multiplied by 2a plus n minus 1. So n minus 1 is 14 times d. Similarly, we'll get an equation from the next 15 terms. Now we have to be careful here, because the formula Sn equals n over 2, 2a plus n minus 1d, it only calculates the first n terms. There's not really a formula that calculates the next 15 terms. That's the sum of all the terms from term 16 to term 30 inclusive. But what we can see from this, what we can deduce, is that the sum of the first 30 terms must be this plus this. First 15 terms, next 15 terms. So it must equal 105. So we have 105 is equal to n over 2, 2a plus n minus 1d. Okay. I'm just going to rearrange each of these equations to make them a little bit easier to work with. So firstly here, I'm going to divide 165 by 7.5. I actually get 22 for that. So that equation becomes 22 equals 2a plus 14d. And in my next equation, I'm going to divide each side by 15. So 105 divided 15 is 7. I get 7 equals 2a plus 29d. So we've solved simultaneous equations like this a million times. I'm going to subtract the bottom equation from the top. That will eliminate the a's. 22 minus 7 is 15. 2a minus 2a is 0. That's why I did it. And I get 14d minus 25d. So I have d is equal to negative 1. So to find a, I simply substitute this into either equations. It doesn't matter which one. If I substitute it into this one here, I simply have 22 equals 2a minus 14. So adding 14 to both sides and dividing by 2, I get a is equal to 18. So this is the sequence 18, 17, 16, and so on. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.